Hi there, my name is Dan Lodu. I am Marketing Manager at QNX, and I'm here today with Bill Peine, VP of R&D for Medtronic Robotic-assisted surgery systems. Thank you for taking the time to be with us.
It's my pleasure. I'm so glad to be here.
That's great. So to get started, surgical robotics is an exciting field, of course. What makes you most excited about the state of surgical robotics today and where you've brought it to in your experience?
Yeah, and surgical robotics has been around for almost 2 decades now, and we've made great strides as an industry. And being able to perform minimally invasive surgery with better dexterity and precision, better visualization, it's really changed the nature of surgery, to be honest. But I think we've only just scratched the surface of what's possible here. Because you have a computer in the loop with the surgeon, you're able to expand their capabilities. You're really able to expand the surgeon's hands, eyes, and brain is the way I kind of think of it. The hands are dexterous instruments, being able to manipulate through very small incisions. Your eyes is the visualization, but there's so much more that's coming in terms of advanced visualization and digital twins and being able to do preoperative planning. And then the AI really amplifies the surgeon's brain. It allows them to have the power of data so that they can predict what's going to happen. They can identify a critical structure with more precision, and they can have more consistency in doing a procedure, more confidence. So it's really the surgical robotics is the nexus that brings in the data, but it's a user interface as well, and it just expands the capabilities of a surgeon.
Yeah, so brings lots of capability today. I know that we are interested, of course, in bringing this technology so that as many patients as possible benefit from it. For your experience, what do you see are the biggest factors in terms of hospitals and clinics both adopting robotic surgery systems and also expanding their existing systems?
So there's several factors that are I would say we need to resolve to really expand the use of surgical robotics. It's amazing how much we've accomplished, but there's still a lot of procedures that are performed open or laparoscopically. Sometimes that's the right choice for that patient, so we need to provide all the possibilities. But expanding the robotics, we need to address cost. I think that's one. We need to make systems that the cost per procedure is something that allows a hospital to have a sustained business. So there's work to be done there. I think there's also important factors of integration, being able to reduce the size of these systems, be able to have them be at different locations where we can bring in robotics to an ambulatory surgery center. But as you do that too, as you start to democratize a procedure and allow robotics to be, more commonly used, I think this is where the analytics, this is where the AI, the advanced visualization, you need to make the procedure easier to perform. You need to give that surgeon, again, the tools they need to be very consistent.
Okay, that's great. So maybe digging a little bit deeper in terms of the content that you just talked about doing those procedures. Any type of surgery can be a life-critical surgery as soon as you go inside the body. So with the hardware and the software systems that drive the robotic-assisted surgery, how do you make sure that those systems are up to the task for the indicated procedure for the patient?
Yeah, it's a great question. It's something we think about a lot. We put the patient first, always. And when you're doing a design of a system, you always say, what if one of my family members was on the operating table, right? And that brings the right level of gravitas, I would say, to the design process. But to be honest, developing a surgical robot is no different than any other medical device. You still follow the same principles. You still make sure that you're doing the design very carefully. You're documenting it. You're creating requirements. You're understanding the usability aspect of it. And then you verify that you can meet the essential performance to perform the tasks. You also think very hard about hazardous situations. What could go wrong here? What could the part of the design could influence that? How could the user interaction cause a hazardous situation? And then you identify mitigations. How can you prevent that? How can you minimize that? And it's very important that you verify and validate every single one of those. So again, the process that we follow is very consistent. We've been doing it for 75 years at Medtronic, making medical devices. But the level of complexity of the ecosystem is more. Again, it's paramount, though, that you do the design properly and you think very carefully about how to maintain patient safety.
Yeah, totally agree. Building on the complexity of the ecosystem.
Mm-hmm.
So as these systems become more and more complicated, you're including feedback loops, maybe some visual systems or imaging feedback directly. How do you, again, make sure that the software component that's driving all of these hardware components and all of this data is also, again, up to the task of synchronizing all of these various tasks that are running either in serial or parallel or some combination?
It's a great question. And what you're seeing is a transition from single devices that treat just one condition to ecosystems, a product, a platform solution, where, as you said, you're bringing in the imaging, you're bringing in the robotic capabilities, you're bringing in electrosurgery capabilities, you're bringing in preoperative imaging and modeling. So integrating all these components together is critical, again, to maintain safety and performance. But you also want to accelerate the pace of innovation. So I think a very important piece of what you're asking about is you need to architect the solution correctly. You need to create software pieces that can be very modular, where you have defined inputs and outputs so that you can redeploy these functional building blocks in the right way again and again, and not have to go back and start from scratch every single time. So building out platforms, I think, is a very important piece of Medtronic's future and the industry's future.
Okay, and I'm glad you mentioned future, because my next question is speaking on future. Where do you see the biggest developments happening in the next generation of robotic systems? Where do you think that the future is going? We've already achieved so much today. You guys have achieved wonderful things.
Yeah.
Where do you see biggest influences going forward?
I think there's three that I would point out. I think one is the integration of AI into these systems, right? That allows you to have the collective power of data, where you can look at nearest neighbors being nearest patients who've had similar conditions and predict the outcome. We're already doing this with our spine business very effectively. But it's also providing that interoperative guidance to the surgeon and being able to direct them so that they can do the procedure, again, consistently and predictably every single time. Second thing is advanced imaging. I think you're starting to see, again, preoperative models that are happening where you can take a CT scan, MRI, and create a three-dimensional model of a patient. Then that allows you to plan the procedure very precisely. Robotics and navigation then allows you to execute that with precision, right? So, and then there's other real-time imaging that's coming in that's really exciting, that allows you to see almost to the molecular level, the cellular level, to make sure that you've got all the cancer removed. And the robotics enables all that. And I think the last piece is really trying to make procedures least invasive as possible. So being able to operate through tiny incisions or no incisions, and being able to go through the natural passageways in the body. And that's a very big challenge robotically, because now the devices have to be long and flexible, and providing that dexterity at the end of something like that is a challenge. But we're seeing advances in materials, in sensing technology, and also on controls and software that is enabling this. And that's going to be a whole new revolution and way of doing surgery.
Okay, excellent. My last question was really going to be about where you saw AI playing a role in the future, but I think you've already touched on that. But do you think that AI plays a role in all of these three areas that you just
Absolutely. Absolutely does. And, I think a natural extension of AI is people talk about autonomy, autonomous robotics, and motion. And sometimes I get the question is AI going to replace the surgeon? And it goes back to what I said. I think you're amplifying their capabilities. You're making their hands, their eyes, and their brain better. But autonomy will play a role in surgical. It maybe is not automating the full procedure, but you might automate aspects of it. Similar to your car, you've got lane departure warnings, and you've got auto stop assist, parallel parking, or tasks that may be tiresome for you, like being able to drive down the highway and hands-free. Right? You can imagine some of these same things happening in surgery, where you're, again, reducing the cognitive load of a surgeon so that they can focus on the tissue interaction. They can make sure that the therapy that is being delivered is exactly what that patient needs.
Okay, so they can focus on the really critical parts of the
Absolutely.
procedure and not focus as much on the entry and exit of that you do every day.
Correct. Absolutely.
Excellent. It's great insights. Thank you very much.
Yeah, thank you. I love talking about this. We've only scratched the surface of what's possible here, and I think we're really at an inflection point with the convergence of all these technologies, and it's going to transform healthcare.
It's great. Thanks.